Virgo's about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grafing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Top stage. Dun, dun, dun. There we go. Stream. What's up, Rigel Kent? I think Rigel's like our. What's up, Shantrix? Good to see you. Our chemistry guy. I think Rigel's a chemistry guy. Kent, aren't you a chem guy? Kimika. Let's see. Let me get TikTok running. Y'all tell me if the stream starts hemorrhaging on frames. I think we're good so far. Yeah, we're good. All right.
Big titties.
Fire up the TikTok. Apparently, so I have ChatGPT kind of like come up with fun announcements for my go live notifications for whatever, for Twitch and stuff. Oh, there's Sensation. We're gonna load the Sensation cam. When Sensation loads, it'll come eventually. What was today's notification? It's Walpurgis night. What is Walpurgis night? Oh, there you are.
I have no idea what's going on.
Oh, well, I can see you at least. You're good.
Nice.
Wow, thanks for the follows, guys. Oh, Seesom. What's up, Seesom? Okay, apparently this is like... This is apparently a night. This is apparently something, Sensation. It's the evening of Wednesday, April 30th to May 1st is called Walpurgis Night, which is apparently observed by the Catholic Church. I did not know this. Oh, wow. I'm a bad Catholic.
I'm Scottish. We're all Presbyterians. So
We're all...
Wouldn't know.
Turn on all
Tough
my lights.
is spelled Tough.
Sir, this is very tough. Let's get it. I got my notebook ready, and I'm in my underwear. It's too much information, dog. What?
Good for you. Now put it on your head and run around outside.
Okay, apparently... Well, okay. Just quickly before we go into questions. Okay, apparently St. Walpurga's Eve is a thing. I did not know this. What country is this celebrated in? Eichstatt. It's German. Oh, it's a German thing. Oh, okay. So it's a German thing. Sensation's camera's frozen. Your camera's frozen. Apparently, Sensation.
It's not me.
It's not me. It's you. Oh damn. Oh, you are right. It is me. You could. Oh, wait.
What is
Hi. What's up, Small? Good to see you, dude. Rigel Kent, Omega Kent, Chemistra, Chimica, Chemie. Nice. That's all good. Well.
Are you speaking English now?
No, Chimica is Spanish. I don't know what Chemie is. I assume that's Portuguese, maybe. Dude, failed to start camera. Dude, what? Dude, is Discord just messing up? Discord's screwing up today. It's okay. Okay. Yeah, today is Wednesday, last stream of the week. I had to teach today again. It's one day before the midterm exams for the students in my class. So they're asking a lot of good questions today. And I'm sure we have some questions during the stream. Oh, thank you, Rippy Moss, making me hydrate. Appreciate it. Professor Gold, can you help me with chain rule problem 31 when you get a chance? I can, Smog, for sure. Did you drop a screenshot for us? So yeah, let me explain to the people that are watching here who have never maybe been here before. and whatnot. Oh, and let me make sure I'm following. One sec. I need to activate TikTok. There we go. That source is on now. So what we do is we're a nonprofit. We help students out with math and science homework, and we incentivize them as well, giving out fun little prizes as they progress in their life, doing good things. One sec. I need to turn this on. Confirm the two things. Great. Awesome. Cool. Okay. So the best way for you to submit a question is there is a link. If you're on the vertical format, you'll see it's actualdiscord.com/submit. If you're in Twitch, that's the link right there. Oh, wow. Is this our anniversary? Do I have a special thing? Oh, I'm the clips leader. Oh, duh, I'm the clips leader. Do you know why I'm the clips leader, Sensation?
Sorry.
Oh, we're still waiting for your camera to work.
No, I think it's my Discord screwing up.
Oh, your Discord's screwing up. Oh, that's okay.
So, clip leader. So he said.
Yeah, clip leader. So if we go into if you go to videos and stuff, you can create clips about things that are happening. And I think so every time a student from my UCLA class asks a question, so this, for instance, this was like I don't know, the two ropes and the mass or something. I just create a clip out of it, and then I send the clip to them so that they can go watch it. I just create a clip out of it, and then I send the clip. I'm hearing myself now. I need to not hear myself so many times. Okay, anyways. So apparently I'm the clip leader from creating all my own clips. If you upload clips from Twitch to YouTube, YouTube suppresses it. Interesting. I didn't know that. Why do they do that? That's rude. Okay. Anyways, good. I got a good question from Jose Luis first. So we'll do that one. The 254 degrees. This is a very good question, actually. So I've done this a couple times in office hours. I will do it online for everyone here who is watching. And some people here aren't from my class. So you're going to learn some physics, whether you like it or not. Okay. So with that being said, let's kick off the stream. Welcome to Office Hours. My name is Dr. Gold, Actual Education. The stream that helps you with math, homework, science homework. All sorts of fun stuff. First question on today's stream comes from Jose Luis, and it's about one of the homework questions that I go through in my physics lecture at UCLA. And it has to do with the magnitude of forces and figuring out what a resultant force is. So here in this question, we say, in the figure below, FB, which is this force here, has twice the magnitude of FA, which is pointing to the right. And they want to find the direction in which the particle accelerates in this figure. Give your answer as a positive angle measured counterclockwise from the positive x-axis. Okay, this is a good one. So whenever I see forces, especially forces that are at diagonals, I always want to break those up into components first. So I know this is a little bit blurry, but I'm going to try and just make it look nice. So here we have that force, and then we have this force. And then here, I'm going to start labeling some things. So we're going to call this FB, and we're going to call this one FA. And we know that the angle here is going to be 45 degrees with the horizontal. Yeah, so this we're going to say, this right here is 45 degrees. Or let's just say it's theta for now, because this could be any angle, honestly. Right, let's just say it's theta. Okay. One second, let me turn this. The volume's too quiet. There we go. I can break up this diagonal force into components that are just up, down, and just left, right. So what I'm going to do is I'm going to break that up into what I'm going to call FBY, as well as another component here, which we're going to call FBX. And then FA already only points in the left-right direction, so we're good. Now what I want to do, in order to figure out the total, well, we want to figure out where the acceleration goes, right? The acceleration will be the same direction as the force, so I need to just add up what these forces are, okay? And they don't give us any values for this, but it's okay. In physics, if you're not given the values, just leave them as letters first, and then hopefully some things will cancel. So if we look in the x direction, let me use a different color. I'm running out of colors. All right. If we look in the x direction, the only forces we have here, right, is FA, which is pointing to the right, so that's positive. And then we have FBX, which is negative. Okay? in the y direction, there is no force of A pointing in the y direction, but there is FB pointing down. So I'm going to say negative FBY. Okay? And that's the only force we have. Okay. So, the next thing we want to do is try to come up with some relationships between all these things. And what we can do is we know we can write FBY and FBX. We can write both of these different components in terms of just this single FB. Let's see, this music's loud. They need to come up with some loudness normalization on this. Okay. So if this is the angle theta, then the sine of theta is equal to the opposite, which is going to be FBY, over the hypotenuse, which is FB. So that tells me right away that if I move this, for instance, this FB up here, that's going to get me that FB sine theta is equal to FBY. And then also for this one will be FB cosine theta is equal to FBX. So we can start plugging some things in so far. So I just have FA, cool. FA minus FBX, which is FB cosine theta. That's in the x direction. And then for the y direction, we're just going to have negative FB sine theta. Does that make sense so far? Jose, who's watching? If you're in the chat or whatnot, it'd be cool for you to say like yes or no. That way I can help you out.
Nice.
Jose says yes. Okay, awesome. Love it. Okay, great, cool. All right, so
Jose says ¿por qué?
Jose, ¿por qué? ¿Por qué, Jose? I used my Spanish yesterday to order some tacos. That's like I dated a girl in Colombia for 6 months, and that's how I really learned Spanish, because I mean, she didn't speak any English, and like I wanted to communicate. And the only reason I like still keep up with my Spanish is to order tacos. My sister's visiting, and her girlfriend wanted to get tacos, and I was like, okay, we'll go to my favorite taco stand down the street.
Okay, so I can confirm that you can indeed say in Spanish what they can probably say in English.
Yeah, probably. I'm decent. I have decent Spanish skills, I think. Okay.
Una mesa para cuatro, por favor.
A glass for four? Is that what we say? A table for four. Una mesa.
Yeah,
table. Table's four. Mesa. Yeah. Okay. White guy surprises Taco Bell with perfect Spanish. Yeah, maybe. Okay. So, I need to relate what FA and FB are. And that's the important thing here. Is they say that FB has twice the magnitude of force of FA. That means that FB is equal to 2FA, which is also the same word for two-factor authentication. Dr. Gold say, pero sabes por qué? Rigel, I think Rigel Kent, correct me if I'm wrong, Kent, but you're from Portugal, I think? I think he's from Portugal.
I was going to say, that's not the way you spelled it, though.
No, he's doing the...
Pero se bains.
No, he's doing the pronunciation. That's how you pronounce it. Why is there nobody here? There are people here. What, dude, look at all the people in the chat, bro. There's lots of people in the chat. There's 14 people on YouTube right now, dude. What are you talking about? There's nobody here. There are very much people here.
There's 30 people here.
Yeah.
Minimum.
All right. But let me do this. So FB is 2FA. So anytime I have an FB, I'm going to replace that with 2FA. So now I have, in the X component, we have FA minus 2FA cosine theta. And in the Y component, we have minus 2FA sine theta. Okay. Right. Next thing I like to do, I know what theta is. They told me theta was 45 degrees. So we should remember that the cosine of 45 degrees is equal to the square root of 2 over 2. If you don't, please do. This one's pretty easy. It's the one where and this is also the sine of 45 degrees is the square root of 2 over 2. They're the same thing. Reason for this is that if you had a unit circle, well, that's a unit square. I was like, that is not a unit circle. There we go. If we have a unit circle, I don't remember this thing from like high school. Having to memorize this thing. This thing sucks, dude. But I would say you don't actually have to memorize it. You just have to memorize two different triangles. If you have this going around like an angle, okay, and this always has a length of 1, then it's going to take on different values as the angle changes. And so what we know is that when this is 45 degrees, this is going to create another triangle. Let me use a different color. That looks like this. Okay. Where this will also be 45 degrees. And now this is a 45, 45, 90. And if this has a hypotenuse of 1, because it's the unit circle means the radius is always 1, then this side plus this side squared must equal 1 by the Pythagorean theorem. And it turns out that this side is the square root of 2 over 2, and this side is the square root of 2 over 2. If you don't believe me, it's pretty cool. You can verify this. So, square root of 2 over 2 squared plus the square root of 2 over 2 squared, right? A squared plus B squared, does that equal C squared? This becomes square root of 2 squared, which is just 2, over 2 squared, which is 4, plus the square root of 2 squared, which is just 2, over 2 squared, which is 4. So that's the same thing as 1/2 plus 1/2. And look, 1/2 plus 1/2 does equal 1. So, yes. This works out. So anyways, cosine, right, was adjacent over hypotenuse, and that's going to be a square root of 2 over 2 over 1. So, you also get your calculators a lot of times on tests, but trust me that this is just nice to know this in your head. It'll help you out a lot later in life. Okay. So, what we're left with now is that FA minus 2FA, and then this is the square root of 2 over 2. That's the x component, and then this is minus 2 square root of 2 over 2, and this is the y component. Cool thing is that the 2's are going to cancel. This cancels with this, this cancels with this, and so now I'm left with my x final component, which we could call this a new vector. Let's call this like vector C. Memorize a unit circle is very useful, and I feel like you only have one. I mean, you have to memorize 1. You have to know that the hypotenuse is always 1. So technically, Enigma, you do have to memorize that one. But it's really only 3 numbers, right? Square root of 3 over 2, 1/2, and square root of 2 over 2. That's all you have to know. And then you can derive everything else like on the fly. It's really cool. I've made videos on this before on TikTok and things. Yeah, I mean, hopefully we assume Enigma that we know that the radius is 1. Oh, Rigel's from Peru. Oh, that's cool. Peru. I've never been to Peru. I've been to Colombia a lot. Medellin, Cali, Cartagena. I've been to a lot of those places. They're cool. Oh, I forgot there's still an FA here. Okay. So now we have our forces, and I'm gonna try to like pull out the FA from here. So that's the same thing as FA, and then it's 1 minus the square root of 2. Which, if you want to do this, ¿Dónde está mi calculadora? No? Where'd you go, calculator? I know you're around here. One sec, I need to go find it. Where is it? Oh, there you are. The wrong one, though. This is the gray calculator. We don't want the gray calculator. What's up, Abraham? Good to see you, dude. Okay. Yeah, if we pull up the calculator here, the square root of 2 is 1.414. Kind of cool. All right. So this is the same thing as 1 minus. So square root of 2 is equal to 1.414. So 1 minus 1.414. This is going to give me negative 0.414 FA. So that's the x component of my new force. And then the y component of my new force is just going to equal to negative 1.414 FA. Okay. Last thing is to try to figure out from the components form here what it looks like in terms of a magnitude and a direction. So if I come back to my coordinate axis here and then draw these components, we should see what the new vector looks like. So the x component needs to be 0.414 FA, and it's negative, so it's got to be to the left. So I'm going to put this and say this is 0.414 FA. And then it also has a y component that is down. Okay. So that's going to be this way. And that's going to be negative 1.414 FA. Okay. Or I'm going to leave this as positive because the down just means it's negative anyways. And from this, we should have some resultant vector here we're going to calculate. And this is equal to FC, which is total. So the question was asking for what the angle was. So they were asking for like, in reality, they're asking for this total angle. But what I'm going to do is just figure out what this small angle here is. This is called the reference angle with a triangle. And what we can do is we can say, okay, well, the tangent of that angle, of this angle, is always going to be equal to the opposite over the adjacent. That's the SOHCAHTOA thing. Where the opposite to this angle is 1.414 FA. And the adjacent to this angle is 0.414 FA. Okay. Now to get theta by itself, what I need to do is I need to take the arctangent of both sides. Arctangent will kill off regular tangent. And then I also got to take the arctangent on this side. So this is now free and becomes theta equals whatever this is. Now remember, we never actually knew what the force was of A. Like, way up here. We never actually got a number, right? We just know that, like, you know, B was twice it. Well, it turns out, once we get down to here, the FAs are going to cancel with each other. So this will cancel with this. And now we're just left with just a number that we can calculate, which is the arctangent of 1.414 over 0.414, which let's throw on the calculator. Let's do it. So arctangent of 1.414 divided by 0.414, and that's going to equal to 73.68 degrees. So theta equals 73.68 degrees. Okay. Now, you may think that's the right answer, but turns out it isn't.
No.
And look, they tried to trick you here. You see how they're like trying to trick you to do this one? They're like, oh, yeah, come on, pick it. In reality, we need more than just this angle. We need the whole angle. And so the whole angle is at 180 degrees first, and then it's plus the 73. And that's why the total angle is going to be 253. Which, yes, you guys got as the right answer. So, congrats. Does that make sense, Jose? Yeah? Hopefully it does. I took my time, like, going through all the steps there and stuff. Yeah, sounds good? Okay, awesome. Nice, great. Congrats.
Good job.
You're very welcome. Oh, Sensation's webcam still out? Okay, whatever. We'll figure it out. Smog says, my high school teacher made us memorize the whole unit circle and gave us a quiz on it. I'm so thankful for it. It helped with higher math. Yeah, I mean, it is very useful to know the unit circle, but memorizing it, man, dude. Not it, dude. I hate memorizing. I'm not a big fan of memorizing. So, yeah, he's talking about this. Unit circle. This, like, cursed thing. Yeah, this. Dude, this is so scary. Like, look at this mess. No, not that. Right, sorry. Wait, I thought I copied it. Copy. Doesn't want to let me copy evil things. Yeah, there we go. Yeah, dude, like, what is this, bro? What? Excuse me?
Surprise, motherfucker.
There you are, Sensation. Have you had to learn this sensation? Have you ever had to memorize this? Do you even know? Do you know what this is?
No.
No, it's okay. This is how you can figure out the sine, cosine, and tangent of a bunch of different angles and things. It's honestly like kind of ugly. I mean, dude, this is like, now there are some symmetries such that if you memorize one quadrant, it's not too hard to then memorize the other ones, and then you just got to remember like where the negative signs go and stuff. Exactly. Yeah. Bessel says I don't memorize it. Shantrick says there's a simple pattern. There is. I think the one they always use, right, is it's like this, right? It's like all students take calculus. And so this is like all are positive, and then this is like sine is positive, tangent is positive, and then cosine is positive. For knowing like whether the identity is positive or negative. Yeah. And you can use that. That's okay. I just still think this sucks. Because in reality, you love the unit circle. I'm glad. Yeah, it's okay. Well, I'm not gonna hate. You know, love is love, dude. Whatever you want, man. It's 2025. I much prefer. Sensations like nope. I hate
everything with passion.
I hate everything. I'm not racist. I hate everyone equally. This is all you really have to memorize, dog. It's really just this. If you memorize these two things, you can do the unit circle forever and ever without ever having to like memorize all those numbers and stuff. You only got to memorize like 4 numbers. Okay. Just always assume the hypotenuse is 1. And then this one is square root of 2 over 2. Square root of 2 over 2. Notice that these sides are the same because the angles they're opposite are the same. This is also called an isosceles triangle. Oh, Shantrix's question? Yeah, we'll see it. Shantrix, did you post me a new one, or is it the same one with the sphere? Because I think I have more bandwidth to do that one now. But anyways, so this is the 45, 45, 90 triangle. So this is the 45, 45, 90. You need to memorize that. So 2 numbers you're memorizing. It's the same one. Good. Okay, we'll do it. This is 30. This is 60 and 90. And this is what we call the 30, 60, 90. Okay? The 30, 60, 90 has 1/2, which is the smaller number opposite the smaller angle, 30 degrees. And the square root of 3 times 1/2, which is the same thing as square root of 3 over 2, opposite the bigger angle. And then once you have these triangles, you can solve anything. So let's look at, for instance, if you had to figure out, I don't know, the cosine of... cosine of 210 degrees. Let's just do it, right? Oh, much love for showing love for calculus. Yeah, nice, dude. I mean, I think this is technically pre-calculus is what this is, but it is also very cool. What is this? One sec. The Rainbow Veteran says, I'm in Civi and I'm having trouble studying concepts like velocity, acceleration, the rate of font, depending on geometry. You have any tips? Yeah, are you talking about like graphs, of position and velocity versus time? Is that what's you're having trouble with? I also...
No. The answer is hammers.
Hammers. The answer is hammers. Sensation says the answer is always violence.
No, velocity, acceleration, rate of filling. Hammers.
Rate of filling. Hammers. Rainbow Vet, if you have a specific question, like if you have a screenshot of a question, that's the best way for me to help you. You send me screenshots, I'll do them here on the stream for you. I'll teach you for free. But let me show real quick just how to do this without the unit circle. So if someone asks you to figure out what the cosine of 210 degrees is, all you got to do is you draw the coordinate system here. And then we're going to figure out where 210 degrees would be. Okay. So 210 degrees, right? You have to go at least here for 90, at least here for 180. So here, right? This would be equal to 210 degrees, okay? Next thing you do is you take whatever the end point of this line is and you always connect it to this axis. Do not connect it to this one. Don't do that.
No.
Always connect it here. Once you do that, you now see that you have a triangle, okay? And this triangle has an angle that it makes with this axis. And that's this. That's this angle right here, okay? This is called the reference angle. And if this whole thing is 210 and going to here is 180, that means this thing is equal to 30 degrees, okay? Now, finally following Jeff's advice of a coordinate system, I know. Now that you know this is 30 degrees, you just got to match it up with what triangle this is. And you're like, okay, cool, this is the 30, 60, 90 triangle, which opposite the 30, I need to have 1/2. And this is negative 1/2 because it's below the x-axis. The other side is the square root of 3/2, which is also negative because it's to the left. And then the hypotenuse here is always 1. And then once you have this triangle, you can figure out all the trig identities for 210 degrees. So the cosine of 210 would be the adjacent over the hypotenuse, which in that case is this. Negative square root of 3/2 all over 1. And so, cool. Negative square root of 3/2. And then the sine of 210 would just be the opposite of our hypotenuse, which is just equal to negative 1/2. I really appreciate your offer. I don't think this many people understand and have fun doing calculus like you in the community. Yeah, I mean, well, calculus sucks for a lot of people.
You done messed up, Aaron!
Which is honestly, it's because most people that are good at teaching calculus or good at teaching math don't want to, they don't want to teach math. Or they don't want to get paid to teach math. They don't want to get paid like nothing to teach math. And yeah, so they go work for Boeing or Raytheon or some science company. This generally makes me happy, so thank you for your work, man. Yeah, cool. I'm glad you're happy today. Nice. Smiles are great. We love that. Yes.
Oh, we're so sorry to hear about your
some
brother
booms for that.
passed away. He
Yeah,
gets
big
5 big
booms.
booms.
You get 5 big booms.
Boom! Boom! Boom!
Okay, anyways. But watch this. So I said the sine was negative 1/2, the cosine was negative 3/2. And you'll see this here. For 210 degrees, it's the same thing, right? You see here how the, I think it goes, yeah, this is cosine, sine. So yeah, cosine is this, sine is this. And we've done it. So that's how we figured out for 210 degrees without having to memorize this. Because this trick here works for all the angles that are multiples of 30, 60, 90, and 45. So, yeah. Anyways, yeah, Smog, there is that one trick. Yeah, the 1, 2, 3, 3, 2, 1, and then yes. Yeah, I've seen that before. It's an interesting trick to do that one. I know what he's talking about. And I think it's on the equation sheet. One sec. Equation sheet, AP Physics 1. I think it's on this one. Yeah, one second. Let me pull it up. Yeah, it's like this, I think. I think this is what it is. Yeah, I think if you go like, what is it? 0, 30, 45, 60, then it's like 0, 1, square root of 2, square root of 3, and then it's like over 2, over 2, over 2. And then the pattern changes. But I don't know, memorizing all those patterns, it's cool. It's a cool hack. But I feel like understanding like where the angle goes and the triangle it forms and what's the opposite, what the adjacent, if you understand that conceptually, that'll help you out so much more, especially when we start considering limits when, for instance, the angle gets closer to 0 or the angle goes to 90. Then it's kind of important to figure out, oh, what's happening to the adjacent, what's happening to the opposite and stuff. Yeah. What are we doing on this live? I see you learned some trig. Yeah, we're doing some trig right now. Let me see. We have some other screenshots that people have sent.
Hold up. He says, what are we doing on this live? Well, what exactly did you expect?
Actual feet? Do they want, the feet pics again? They want the feet pics again? I can't give the feet pics.
What was the weirdest thing I ever saw? There was a guy's foot and his pinky toenail was so long it was curled around itself.
Oh, dude, that's gross. I don't know about that one.
Just that one. Not the rest of it.
I don't know about that one. Let's see. Swa submitted a question. Smog, you had one. Sorry, your question was on. Let me go find it. Sorry. It was 31 on the, and then Shantrix, we'll do yours. Oh, here it is, 31. Here, let me just do this one because he hasn't asked the question in a bit. Find dy dx. Is it this one? One second, I'm pulling him. This is some calculus.
So basically, we send questions and you'll help us with it.
Yeah, I will.
Yes.
Yeah, dude. Yeah.
We do.
Yeah, send a question. I'll help you do it, dog. We'll do it live on the stream. Watch. Okay, we're gonna do this
For
one.
the love of God, use proper English.
Yeah, otherwise Sensation will come get you. He's gonna haunt you down. Okay, Smog, is this the one you needed help with? 31? Yup, okay, let's do it. Alright, so we have y, y cosine of x is equal to x squared plus y squared. So this is implicit differentiation, and I have my strategy for this, which it does pretty well on YouTube. It's actually, I think, one of my most popular YouTube videos. One second, let me go find it.
Implicit differentiation.
Yeah, studio. Did some of you guys find me here from implicit differentiation? I wonder if you did. If I go to my content here, and if I go to, I believe it's my shorts, and I go to the most amount of views. Yes, yeah, look at this. My implicit differentiation video is my highest one. 114,000 people have watched this video. But yeah. Here's an easy way to do it. Dude, I did this is low quality. I made this, I think, probably 4 years ago. So here we have a pretty messy equation. But yeah, if you ever want to learn implicit differentiation, go check out my channel there. I'll go over it right now anyways, but for those of you that are watching and like wondering like where did this come from? That's my short on it. Okay. But what I like to do here, Smog, is I treat every variable as something that I'm going to take a derivative of. And whenever I take a derivative of that thing, I write either like dx or dy, depending on what it was. So when I look here, okay, I notice that I have two separate things, right? I have something being multiplied by something else. And that to me is a product rule, right? When I have AB and I take the derivative of that, that's the same thing as A prime B plus B prime A. Do we remember this? Do we remember the product rule? If you got two things. Yep. Okay, cool. So I'm going to do the derivative of this, right? The A thing first, which is the derivative of y is just 1. And then because I took a derivative of y, I'm going to write dy. And then, right, it's times regular b. Well, regular b is just cosine x. So I'm going to just leave it like that. And then plus, we're going to do the derivative of the second thing. Why wouldn't you do dy dx? Because I don't like that way. The reason why, Smog, I don't use dy dx is it gets confusing, especially when doing product rules and doing this, to remember which thing you're taking derivatives of. If you always tell yourself, whatever I took a derivative of, write dy or write dx, it'll work. And I'll show you. Anyways, okay. So then it's b prime a. So the derivative of the second thing, derivative of cosine of x, is negative sine of x. And then because we took the derivative of x, I'm going to write a dx. And then it's times whatever a was, in this case, which was y. So this is just going to be chill. It'll just be y. Okay? And then it's going to be the same thing over here. So the derivative of x squared is just 2x. And because I took the derivative of x, that's a times dx. And then the derivative of 2y is just 2y. And the derivative, and because I did a y, that's a dy. Okay? The next step I like to do is I'm going to group everything with dy on one side and everything with dx on another. So I'm going to move this over here. So that's going to give me, let's do all the dy stuff in purple. So I'm going to say cosine x dy minus 2y dy. And then everything with the dx, I'm going to put on the other side. So we're going to move that over. So this is going to be equal to 2x dx plus sine of x dx. Okay? And now I'm going to pull out the dy from everything here. So this is just going to be dy cosine of x minus 2y is equal to dx, and then this is 2x plus sine x. Yes, strict sense. Yeah, Rigel, you're exactly correct. Dude, everyone goes on fucking suicide alert when I show them this trick. All the math people do. Because they're like, bro, you can't just divide dy by dx. And I'm like, well, you can. You can for the first derivative. And 90% of the time, that's what kids get screwed up on. But Because now what I'm going to do is I'm just going to divide this side by dx, and I'm going to divide this by the other thing. So I'm going to just take this, and I'm... I fucked up. And I'm going to move it over here, right? So now we have this is equal to, and then I'm going to take this, and I'm going to move it under here, and now we have this. And then this is your answer. dy dx is equal to 2x plus sine x over cosine x plus minus 2y. And it's right. It works. Purist mathematicians get the cramps. Yeah, no, exactly. This makes math people like so mad. They're like,
You're getting to the hospital now. And I just said, just shut up and let me enjoy this pain.
They hate this. They hate that I do this. What if you have... Good. So, exactly, Smog. He says, what if I have cosine of xy? I'm gonna tell you right now. That's why this method is so much better than doing dy's and dx's. You can formalize the argument by pretending both x and y are functions of a third parameter, t. 100%. So, I could have said that, yes, whatever, x is equal to x of t, and y is equal to y of t. And then really what I'm doing here is I'm doing this, dy dt, I'm doing this, dx dt, so forth and so forth, and then I'm canceling them out. Yeah. So Rainbow says, speaking of differentiating, you know how efficiently memory's is in the realm of ln? Natural logs, is that what you're doing? I'm not a big fan of memorizing. I really don't like memorizing. I kind of discourage it. Some students that are in my physics class are asking, oh, you know, will we be given certain like formulas for things? And I'm like, if the formula's on your equation sheet, you're good. Anything else, like the range equation or like simplifications for like pulleys and stuff, those are only special cases. And you don't want to keep trying to memorize a bunch of special cases because there's a lot of special cases. And take it from someone who teaches every single course, basically math or science, from high school and middle school up through early college. I can't memorize everything. But what I can do, so the less I have to memorize and the more I memorize like little pillars that work, the easier it is for me to just like rederive it on the fly. What's up, FemFox? Yeah, Smog asked, what happens if I have cosine xy? So that's a good question. So let's say, for instance, you had cosine of xy was equal to, I don't know, like y squared. And you wanted dy dx, okay? Well, then this is cool. Because this becomes a chain rule. So let's remember that the derivative of cosine... So I'm just going to do the derivatives of things. So this side's easy, right? Derivative of y squared is just 2y dy. And then for this, okay, so this is a chain rule. So this is equal to the negative sign of whatever is inside, right? Times d this, d whatever. Okay. Okay. So I'm gonna write this just as d whatever for now. Okay. This is a chain rule. Is this GCSE maths? I don't know what this is. I think it's maybe high school or college. Okay. So, right? Because derivative of cosine of u is going to be negative sine u du. So, this now is negative sine of xy. But now we have to do the derivative of xy. And the derivative of xy is a product rule. Right? So, that's negative sine xy. And that's going to be the derivative of the first, which is just 1. So, dx, because we took the derivative of x, times y. Plus the derivative of the second, which is just 1, dy, times dx. Oh, wait, sorry. 1 dy times x, not dx. Yeah, there you go. And this is equal to 2y dy. So what you're left with is negative sine xy, y dx. See, there's a y there and a dx. And then minus x sine xy dy is equal to 2y dy. You're going to take this and put it over. So let me just move things around. So this comes over here. Oh, I lost my hat. Sorry. Come on. I need to grab you. There you go. Okay, cool. And now I just group things by dy. So dy. So this is 2y plus x sine xy dy. And then this is whatever dx. So I'm going to move this over here. And then I'm going to move this over here. Oh, let's get rid of this. And then you have your answer. dy dx is equal to this like kind of big jumbly mess. But that's how to do that. Oh, you're good, Kent. Yeah, I'm back on Twitch. Yeah, I think I am for now. The streaming's still working. Okay. Does that make sense, Smog? This kind of falls apart if you have to do the second derivative. Then you do have to do the dy dx stuff. Oh, I see it's the same with the inverse of tangent. Yeah. Yeah. Is it A level? I don't know if this is A level. Maybe. Okay, cool.
It's pure maths. It's pure maths A level, definitely.
Pure maths A level. Nice one. Good question. All right, I got a couple screenshots coming in. Well done. Smog says this is calculus 3 for him. What's up, Dry Nose?
We don't make the differentiation. There is lower level and high level.
Yeah. Lower level and high level. All right, let me see. What else have I got screenshots? Swa, are you around here? He has a double. I see he has like a double E question. That's a good question. This one right here. Let me pull this one up. This is and then Shantrix. We'll take an attempt on we'll take a second gander at your cube and a sphere thing. What's up, Guitar Ninja? What's up, my dog? Okay. Let's see what happens here. So it says 2 cubes of A and B of same dimensions are made of different materials with densities rho A, rho B. Cube A floats in water with a fraction of n of its volume immersed. While cube B is placed on top of cube A, it is found that cube A is just entirely immersed, while cube B is entirely above the surface of the water. What is the ratio of rho B to rho A? This is really cool. Okay. It's actually kind of related to what I've been teaching, because it has to do with force diagrams. Okay. It has to do with something a little bit more advanced, though, because it has to do with buoyancy. So, let's pretend that we have a jar of water, I guess, right? And we have Sir Cube here, which has a density of rho A. Okay. Or rho sub A. Where's my sub A? Okay. So, the forces on this cube, by the way, if this is hydrostatics, yeah, this is pretty cool. So, if it floats on the water with a fraction of its volume immersed, and then they say they're the same dimensions, by the way. Okay, so if they're the same dimensions, then they have like VA is equal to VB. Like they have the same volume. Okay, we're just gonna say it's equal to V. Okay, then there are a couple forces here on rho A, on block A. So there's the force of gravity pulling down, which is going to be equal to mg. And then there is what's called the buoyant force, which here is equal to the buoyancy. Let's call this FB. And the definition for buoyant force is it's equal to the volume submerged times the density of the water. And I want to say there's a G term in there as well. Is it? One sec. See, this is where I don't remember everything. Buoyancy equation. Oh, it is. It is rho GV. Okay, cool. I was right. Fluid density, G's. Okay, gravity. Okay, cool. Awesome. Right. So that's rho V, and then it's also equal to G. In this case, it's negative because it points up and gravity points down. But I'm just going to leave it like this. The minus signs are like whatever. Okay. Now, we know that cube A has a fraction of its volume submerged. So V submerged divided by the total volume of A, that is equal to eta, or is that eta? Is that what we call this thing? Do we call this thing eta? Okay, so Vs, the volume submerged, is equal to eta V. Okay, so then force buoyancy here is equal to eta V rho A. Or no, just rho. It's the density of the wait 1 sec. It's the density of the fluid that's displaced, right? Which is just rho. We're gonna say rho is equal to the density of water. Is it? Does my eta look backwards? Oh, my eta does look backwards. Oh, this one's supposed to be the long leg. Oh. Okay, well, whatever. Mine has the leg on the left. You are right. You are technically right, Finvox. Okay. So I'm going to say eta V rho G. Okay. That's equal to the buoyant force. Okay. And then the force of gravity, right? That's equal to the mass, which the mass of block A is equal to rho A times the volume times G. So density times volume, that gets me mass. And then times G, that gets me the force of gravity. And if this thing is in equilibrium, that tells me that the force of buoyancy trying to keep it up has to equal the force of gravity trying to pull it down. So what I will say, my grand conclusion here, is that eta V rho G is equal to rho A V times G. So some nice things cancel here. The A's cancel. Don't got to worry about the A's. Or sorry, the G's cancel, so what I meant to say. The V's cancel as well. Oh, very cool. So I actually don't need to know the volume of the cube. And I get this cool equation here, which is just that the density, eta, which is the proportion that is submerged times rho is equal to the density rho of cube A. Okay, cool. All right, so that's situation 1. Situation 1. Okay, now something else happens. This is situation 2. And this is where, like, this will help the stuff that we learned in my physics class. Because this is exactly all the stuff. So in situation 2, we say that cube B is placed on top of cube A. Okay. So let's say this is cube B, and it has a density of B, and that cube B floats entirely above the surface, but A is completely immersed. All right? So now we have to start drawing some force diagrams on things. So what I know for... and we got to draw separate ones. So here. So for the B block, rho B, that's going to have the force of gravity pulling down. So force of gravity, which is going to be equal to mb g. And then it's going to have the normal force pointing up, which the normal force for this is going to be the force that A pushes up on it. So we're going to say FA on B. Okay? Now for the red block, and notice this does not have any buoyancy force because B block is not in the water. It's completely above. It's floating on A. Or it's not floating, but it's, it's above the water on A. A is completely submerged. A also has a force of gravity, which is equal to MA times G. It also experiences the force of the B block on top of it. So it's going to have an equal and opposite FB on A. And then it's going to have a singular normal force, or not normal force, this is going to be the buoyancy force, trying to keep it up. Okay? Common thing people will sometimes get wrong is they'll be like, oh, well, this must also have FA on B, right? Pointing up.
Surprise, motherfucker.
And it's not that. You always, when you're writing force diagrams, you look strictly at what is happening to my block. Not what my block is doing to other things. This block feels B on top of it, and that's B on A. And whatever it feels from B, B needs to feel from A. So this force and this force are equal, but in opposite directions. And this is called a reaction pair. This is Newton's third law. So by Newton's third, FA on B is equal to FB on A. But they're equal and opposite. Okay. So looking here, right? We can sum the forces in the y direction. And we're going to get that FAB is up minus MBG, which is down. And this has to equal 0 because we assume things are static. So there's no acceleration in the y direction. Here, I have the buoyancy force minus FBA minus MAG, and that has to equal to 0. Now, the cute thing here is that since FAB and FBA are the same, so the force of A on B is the same as the force of B on A, I can rearrange this to say, oh, FAB is equal to MBG. If I just move this over. And now this can get slammed into here. So now I have the buoyancy force minus MBG minus MAG needs to be equal to 0. Okay. Let me move this G up. Now, the mass of this, right? That's the same thing as rho B times V. And this is the same thing as the density of A times the volume. Okay? So G minus G. And then buoyancy force, let's remember, is equal to rho of the water times the volume that is submerged, which the volume that's submerged is the entire block A. So that's just going to be V. And then it's just G. So this is what we have. We have rho VG plus, minus rho B VG minus rho A VG has to equal to 0. Okay. So now I have two like conclusions here, which I think are cool. Also, did we use any of our etas anywhere? What the fuck was eta? Oh, we didn't use eta because eta is the percentage that it's submerged, and it's entirely submerged. And what do they want? They want rho B over rho A. Okay. So here, we got this, right? And then we also have this statement from before. This was from part 1. So, in my answer here, I notice I want everything to just be in terms of eta. And I don't want, and I'm allowed to have rho A and rho. Is this AP Physics 1? This might be actually. Is this AP Physics 1? Who asked this question? This is quite difficult, honestly. I don't know. I would not put this on AP Physics 1. This is really fucking hard for AP Physics 1. Oh, wait, one sec. I copied this down wrong. There we go. It's Archimedes' principle, yeah, but I don't think it would be covered in AP Physics 1. Sorry, let me move. I have too many things over here. Okay. So, I want to cancel out rho because rho is nowhere in my equation. So, I'm going to solve for rho here. And I'm going to say, oh, rho, which is the density of the water, is equal to rho A over eta. And now I can substitute that into here. And let's see what happens. So now I get rho A over eta. Am I going to start drawing my etas correct this time? I think I want to now. I'm going to start drawing etas correct. And then VG minus rho B VG minus rho A VG equals 0. All the VGs go away. Look at these. Goodbye. Don't need this. Don't need this. Don't need this. Let me group the rho A's together. So I'm going to have rho A, and then this is going to be 1 over eta minus 1. And then I can move this over, is equal to rho B. And I think they wanted rho B over rho A. So I'm going to just divide this over. And I'm going to get that rho B over rho A is equal to 1 over eta minus 1. Which... Okay, none of these answers yet, because I got to simplify this. When this doesn't look like any of our answers, because it's got to be like slightly different with the geometry. I'm going to multiply by eta over eta here. And we're going to see this works out. So eta over eta. And that gives me 1 minus eta over eta is equal to PB is equal to rho B over rho A. Come on, give me an answer here. Yes, that's choice D. And there we go. That's it. Nice.
That's dope.
Wow.
Well done.
That's a really cool question. I like who... I think Swa submitted that one. Thanks, Swa, for that. That was cool. What's up, Sensation?
It's not working yet.
You know, it may be me. It may be me, honestly, Sensation. It's probably me, dude. Because I'm seeing failed to start camera. I probably have to restart Discord. Yeah, it's probably me. Which I could restart Discord, but
no.
I worry it would start killing other things.
Yeah, it's not worth it.
Yeah, it's okay. Very nice solution. I thought it was cool too. Yeah, thanks, man. Diesel. Whoa, yo, look at all these questions. Area of the plain region. Whoa, this is fun. Look at what Diesel's like sending us right now. One second, let me pull it up. Look at all this. Well, yeah, it looks like you're doing... this looks like Calc 3. Is this triple integrals? Yeah. Kind of looks like triple integrals. Nice pen.
See,
I like the pen there.
People still do use paper and pen.
Yeah, this is dope, dude. Okay, very cool, Diesel. Appreciate all the things. We'll get to it. We'll get to your question. Don't worry.
That's the point. What do you call Tipex?
Pardon?
What do you call Tipex?
What do I call JPEGs?
No, Tipex.
What the fuck is Tipex?
The white stuff on the paper.
White stuff on the paper. Wait, what white stuff is on the paper? Wait, what? All right. One sec. Please hold. Oh, whiteout. Are you talking about whiteout? You talking about this?
Yeah.
Yeah, where
its brand name.
Oh, you call it Tipex? We call it whiteout.
Yeah.
This is an old school thing. I don't think many people have seen this.
I haven't used Tipex in millennia.
Yeah. Veteran says, yes, it is, sir. My real name is Diesel, by the way. Bro, that's dope. His real name is Diesel?
Sauce.
Yeah. Femvox says liquid paper is what they call it. Orgo solvents. Yeah, those leaf-looking paper is mandatory in my school in the Philippines. Wow, that's cool. Look at us, international. We're helping students across the world. Okay.
Filipino.
Diesel. Because you've never asked a question in my server before, I'll skip ahead to yours. And I think Shantrix he said he was out for a second. What do you need help with, by the way? Are you trying to find... I see volume of revolutions. That's cool. Do you need help with volumes of revolutions? I can explain that to you. Or... I'm trying to understand what's going on here. Is this the area between three curves? Is this an example of something you need help with? Or... This to me also looks like the area between three curves. You tell me what's the most useful for you. Like, what do you have the most difficult time with? And then I'll help you with it. I'll help you do it. This is a cool one. I like this one, actually. I really do, actually. This is a cool one.
Oh. In international news, did you hear that
Yeah.
all of Spain lost its power?
I did hear that. Spain did lose a lot of its power.
You misunderstand. All of Spain lost.
Wait, the whole
all of its
country?
power.
The whole country
The
lost its
whole
power?
country.
Oh, damn.
As I understand it, so did Portugal.
Yeah, well, Portugal's kind of connected to it. Portugal and, like, Spanish just party with each other.
But yeah, for an entire country to lose its power, I mean...
How did the entire
Spain's
country...
massive.
I mean, Spain's kind of fucked up, but, like, how did they lose it? How did they lose all their power?
To be honest, I don't know.
Oh, okay. I'm waiting for Rainbow Veteran on YouTube to tell me which one he wants me to do. Otherwise, I'm just going to pick one. Because this is actually, they're all really fun, actually. They're all really cool questions, honestly. Very interesting that they're having him do this. I have solutions, but I'm not sure if I'm correct. Find the enclosed area for the first two and volume for the third with 2 techniques. Okay, find the enclosed area for the first two. Oh, I see. This is his question. Okay. Yeah, let's see if we get the same answers. I see what he's talking about. Okay, one sec. And this will be very useful. These are useful calculus things to know for sure. So, area of the plane regions. I assume this is y equals x. Jesus, your handwriting. I'm sorry. Y equals... I don't know what this is. What is this thing? 2e? Is it 2e? Really? And x plus y equals 6?
Delta.
I agree, brother. Questions like these scratch my brain the right way. I mean, they're cool. Just tell me what this is. Please. Oh, keep up the good work. Okay. Oh, this is 2x. Okay, it's 2x. Thank you, Fembox. Okay, let's just do it. Let me do this one. And we'll see if it's something nice. Okay. So, the first thing, whenever we want to figure out the area of a plane in a region, is you want to try to make a rough graph of it. You don't have to be exact with your graph, but you should be kind of close. So, here we have y is equal to x. I'm going to call that this graph in blue. Okay. So y equals x is going to look something like this. Okay. And then we have y equals 2x, which is going to look like it's even steeper. Okay. And then we have x plus y is equal to 6. So x plus y is equal to 6. I'm going to get that in regular slope-intercept form. That's y equals negative x plus 6. Okay. So I know I'm going to go 6 up. Let's do that in the... I want a different color. Let me do that in the red. Okay, so I'm going to go 6 up, probably up here somewhere, right? And I'm going to come down with a slope of 1. So that's going to be something like this. Okay, and they want you to find the area in between this whole region. Okay. The first thing you want to do is you want to figure out where the intersection points are. So the best way to do that is to take all your equations and kind of set them equal to each other. So if I set y equals x and y equals 2x equal to each other, right? If I do like y equals x equals, 2x, the only solution for that is x equals 0. So it's obvious that they meet here, right? So this is 0, 0. This is one of our meeting points. Let's figure out this one. So I want to know where negative x plus 6 corresponds with y equals x. So I'm going to say x is equal to negative x plus 6. And that's going to get me 2x is equal to 6, so x is equal to 3. And if x equals 3, y equals 3. Okay. So this is another point here. And this is going to be 3, 3. And then now let's get this coordinate point right here, which is going to be... This is fun. There's actually a fast way to do this. So if 2x is equal to negative x plus 6... then 3x equals 6, we get x is equal to 2. And if x is equal to 2, y is equal to 4. Okay, so this is 2, 4. Okay, right off the bat, you can kind of do this one easily because this line here and this line here are perpendicular to each other. And the reason they're perpendicular is that their slopes are opposite reciprocals. So technically, this is a right triangle. And we're just figuring out the area of a right triangle. So this would be the easy way to do it. You just do base times height, and it's honest. It's pretty cake. And here, let me get the answer. So before we do it, just so you can kind of see what would happen. But your teacher wants you to do it using integrals. I'm just going to do this to verify, right? So because this is a right triangle, I need the height. So the height is the distance between 0, 0 and 3, 3. So that's the square root of 3 squared plus 3 squared. So that's the square root of 18, okay? That's what this distance is. And then this distance is going from square root of 1 squared plus 1 squared. That's equal to the square root of 2. So then 1/2 base times height should get you 1/2 square root of 36, which square root of 36 is 6, so that's 6 over 2, which should get you 3. Which I think is what you had. And so, yeah, that's the easy way to do that one. Because you can literally just recognize this right triangle. If you wanted to do this with integrals, which we can do, that's okay. Let me delete this over. Get rid of this. Okay. You have to pick an axis to go down first. So I could either go like dx and then do y minus y, or I could go this way and then in terms of dy and then do x minus x. I'm going to choose to do dx first, okay? But when I do dx, so as I'm integrating like slices here, the issue is that what my top function is and here is different. So from 0 all the way to 2, my top function here is the 2x and my bottom function is the y equals x. But from 2 to 3, my top function is the negative x plus 6 and my bottom function is the y equals x. Okay? So we have to find a split point, because what is the top function changes as we integrate. So this is going to be the integral from 0 to 2 of my top function, 2x minus my bottom function, x, dx, plus the integral from 2 to 3, so that's going from here to here, of this function, which is negative x plus 6, and then that's minus x, y equals x, dx, okay? So if we integrate this, this is just 2x squared over 2 minus x squared over, well, 2x minus x is just x. So first of all, let's just simplify that. That's just x. Integral of x is just x squared over 2, and then that's from 0 to 2. This is negative x minus x, so that's going to be negative 2x plus 6. So integrating that, you're going to get negative x plus 6, or you're going to get negative x squared plus 6x, and that's going to be from 2 to 3. Okay? So here, evaluating the things. Okay, Shantrix, nice. We're going to do yours next. We get 4 over 2, which is 2. And then minus, so this is going to be plugging in 3 first. That's negative 9 plus 18. Minus negative 4 plus 12. Okay? So now we have 2 minus 9 plus 18. So this is 2 minus 9. And then it's going to be minus is plus 16. Did I do that right? Because that's negative 7 plus 16, which is equal to 9. But I want the answer to be 3. Move something squared. What did I do wrong? 2x minus x squared over 2, 0 to 2. Yeah, cool. That's fine. Yes. Well, this one, okay, but here I had negative x plus 6 minus x, so that becomes negative 2x. So that becomes over 2 over 2. So that just becomes negative x squared. And then this becomes 6x over x. And then we plugged in 3. Oh, I fucked up the minus signs. That's why. My bad. Sorry. It's plus. It's this one plus this integral. Or this, yeah. What's up, default user? I'm doing some calculus here. This is negative 9. Negative 9 plus 18 minus, and then this is negative 4. Well, okay. It's yes. You got to keep track of all the minuses here, which is annoying. It's minus, and then this is negative 4 plus 12. So that gets me 9 plus 4 minus 12. So 9 plus 4 minus 12 is 13 minus 12, which is equal to 1. And then 1 plus 2 is equal to 3. Same answer. And you're good. Nice.
Well done. Well done.
That's a cool question. Diesel. I hope this made some sense to you with like how we did it. Yeah. Because the other question you had here, with the plane, it's gonna be kind of the same thing. You graph, you find the intersection points, and then you split your integral up between top and bottom for a bunch of them. The volumes of revolutions is gonna be a little trickier. If I have time, I will go through and do these. But let me help out. Let me do Shankrix's and let me do Adarsh's. Okay, so here. Let me do Shankrix's first. This one was fun. I actually like this one. Okay. Math challenge question coming up. Okay. This behemoth. And then who's submitting questions to me? Nice, Hanifa. Ooh, yeah. Oh, nice. That's cool. Yeah, the constant velocity one. Yeah, I'll do that one next, Hanifa. That's a good one. Okay. All right. So cylinder has radius 12 and a height of 30. And cool. Oh, yeah. Thank you, Rainbow. You're good, dude. Okay. So I know that this distance here is equal to 12. Okay. So that tells me... And then we know the height is equal to 30. I think actually, Shantrix, I think I know where I messed up. There we go. This is 30. Oh, the radius is 12. Oh, okay. Well, I fucked up. I fucked up even more. So, okay. Yeah, all right. I saw this. Okay, thank you. Yeah, let's fix that. I was looking at extra problem for midterm 2, and the first problem I was a bit confused since I didn't have the mass. Yeah, again, if you don't have the mass, always just put M, Nini, and it'll usually cancel out if you just carry it. You should see, but I can also go through it. It's okay. Okay, and then what did we say here? Okay, we said that this distance right here, right? This must be equal to 30 minus R. Because this is also equal to R, right? And then I said, okay, if this happens like this, that means this to this, these must be like perpendicular with each other. My question. If this happens, I do believe this is equal to this. I feel like that is a property of... I think that's like a circle theorem thing. Yeah, here we go. Where's this thingy? Yeah. Yeah, so this is it. Okay. So because of this, I know that this length must be equal to this length. So this length here is also 30 minus R. Let me use a different color for it. This is also 30 minus R. And this is also 30 minus R. Okay. Now, here's the thing I want to know is, can we assume that this angle is equal to this angle? Can we assume that it bisects it? I kind of want to say that it does. Let's see, because they both have a 90. I feel like it has to. I feel like this angle must equal this angle. I have SAS on those triangles. Oh, you're right. Yeah. Okay. Side, angle, side. Okay. So yes. So the angles are the same. They are similar triangles. CPCTC. Nice. Thank you. Yes, good. Okay. Sorry, what am I trying to solve for? Oh. What's the radius? Okay, what is r? Okay, cool. Alright, so r is equal to this thing right here, right? So I believe if I can get this angle, then I can get this angle, and then I can probably make some nice little diagrams and stuff to get stuff to work. Okay. Well, I do know what this angle is equal to, right? This is theta. Because I know the tangent of that angle, so tangent of theta, is equal to 30 over 12, okay? This is where Jeff was saying, do the arctan. Just do it, man. Okay, so theta is equal to tangent -1 of divide by 6, sorry, that's 5 over 2. Okay. I can use my calculator. I could probably do this in exact form, but I don't want to. Okay, so tangent of 5 over 2. So that's 68.19. Okay. Underrated Chad, this guy. W, dude. Appreciate that, dog. Underrated Chad. So if that's 68.19, then that tells me that 2 times this other angle here, right, this blue one here, this 2 plus this have to equal to 90. So this is equal to 90 minus 68.19. So 90 minus... I think I had this, Chantrix. Why did I get the wrong answer? And then I'm going to divide that by 2. And so I'm going to get that theta is equal to 10.9 degrees. Okay. Now that I know this is theta, I can say that, oh, well, the tangent of that angle theta is equal to the opposite, which is r over the adjacent, which is 30 minus r. What's up, Zach? Good to see you, dude. No, bro, I was so close. Dude, I swore I had this. No, it wasn't this one. Where was it? The house. The math. Yeah, dude, look at me. Look. I had this. I had the 68.2. I had this. Oh, you know where I fucked up? I used this angle, and then I did the whole triangle. That's why I wasn't getting the right answer. Okay, I need to use part of the mini triangle. All right, yeah, good to see you, default user. What are you eating? What's for dinner? I'm hungry. My sister's in town for one more night, so I got to go out to dinner with her in like 30 minutes here. Okay. All right, we're so close. We should just get this. Let's just rack. Let's rack it out, guys. So the tangent of that angle is equal to 0.1925. So 0.1925 is equal to r over 30 minus r. So 30.1925 minus 0.1925 r equals r. Move that over. 1.1925 r is equal to 30 times 0.1925. Okay, so then we just divide, right? So that times 30 divided by 1.1925, and I get 4.84, which, yeah, look at that. That's answer choice A. Fuck yeah, nice, good job.
That's dope.
Oh, that's cool. That felt good. Okay. Cool, man. All right. Adarsh, where you at? I'll do yours, Adarsh. Did you get a chance to look at the equation on the one problem? Yeah, thanks, Zach, for sending me that. Zach sent me... You sent me... One sec. It was... Was it in math chat? You sent it to me. Oh, is it in your prompts? Where... Sorry. You have a... I want to say you have... Oh, this one. Yes, this one right here. Yeah, so it's funny. Yeah, this is engineering is what this is. This is specifically statics. So the students in my UCLA class are probably like, oh man, force diagrams. But they have no clue that there is an entire engineering class just dedicated to doing force diagrams, and it's called statics.
You done messed up, Aaron!
And this is what they do. So it's just like super force diagrams everywhere. That's all they do. They just draw force diagrams. And honestly, I feel like this class is just tedious. Because, like, bro, we get it. We get the concept. It's like, yeah, we get it, you vape. Like, we get it. Force diagrams. But why the fuck do I need to do it for, like, 19 different things? The electrical current problem? Yeah, I'll check it. Guitar Ninja. Let me do a Darsh's real quick, because he's been waiting. And then I'll go to that. And then I know there's a physics one as well I need to do. And then, yeah, we'll rock our Roozies. Statics. Yeah, dude, I don't know. To me, it's just, like, annoying. All right, Adarsh, let's see. It says if y equals ax squared, if the function passes through this, what is the value of a? Well, that's not bad. This is, again, like, these are points, right? This is x, and this is y. And so what this tells me is that f of x is equal to, technically what we say, like, is y. And that's also equal to a x squared. Okay. F of x is equal to ax squared. And f of x is kind of usually just written as like y. Okay. So, if you want to solve for a, you just got to use a point. That's all a function does. A function takes x values and tells you what their corresponding y values are. So, if you know the x that goes in and you know the y that comes out, you can figure out what happened in between. So this is negative 115.2 is equal to a, and then this is going to be negative 12 squared. So that's going to be 144 times a is equal to this. Okay. Just divide by 144. Divide by 144. Which is not a nice number, unfortunately. What do we got? 115.2 divided by 144, and that's equal to 2.8. Actually, that's cool. All right, so a equals 0.8. Nice. Nice, it was correct, Chantrix. That's awesome. Chantrix showing us the solutions for the last one we did, the Fermat competitions. Yeah, here it was. Very cool. Yeah, you're welcome, Adarsh. Nice. Very cool. That's what the solution to that one was. Yeah, okay, cool. Let me give a coin to Chantrix as well. That was a good one. Okay, let me go through the list. Who submitted stuff? Give me a second. Hankinator. And then Dry Nose, I know you've been waiting as well. This is gonna be a ratio test, is what this is gonna be. I'm pretty sure. Pretty sure this is a ratio test. Or actually, it's alternating, isn't it? That's an alternating series test. Okay, but one sec. Dry Nose just keeps hitting me with the convergence. This is also the ratio test. Anytime you see exponentials, dog, it's ratio test. Always a ratio test, yes. Shout out also to Zach. Zach is a great guy and is awesome with math. If you want to figure out when he's streaming, because, maybe, it's getting busy and you have to go eat lunch or it's a different time zone. He streams Math Help at probably a friendlier time for the European or international students. So there's the calendar if you ever want to check it out. So that's Zach right here. And so he streams at 8:30 a.m. my time, which I'm not awake. But for some of you guys, that's probably... I'm in Los Angeles. That's probably when you guys are actually awake. So, yeah, make sure to check out that calendar, and you can figure out when he's streaming. Yeah, I appreciate, Zach, you're taking the morning shift. Number theory seems too hard for me. You too can wake up at 8:30. Yeah, I can stay up till 8:30. I don't want to wake up at 8:30. Oh man. I'm so glad when UCLA gave me this course that it was not like an 8 a.m. class, because That would hurt my soul. I would seriously reconsider my appointment. I'd be like, I'm just not going to make it. I know myself. Okay, here, let's do some double E. And then the person who submitted the physics question on, let me show you. It was this one. I will do this one next. And then Dry Nose, I will do one of yours. I'll do one of your series. And then if Diesel's still around, I'll do more of yours as well. Okay, cool. Does that sound good? Sound like a plan? So you know the stuff. Okay. The resistances of 4, 3, 6 are connected to an 18-volt battery as shown. The net or overall resistance. I love these. Circuits are fucking dope.
That's dope.
I love dope. Yeah, dope. Yeah, dope.
Man, look at that. Look.
Yeah, circuits are really cool. I love circuits. Anyways, okay. So here's what we're going to do. Circuits is like a bunch of like collapsing like little Russian dolls and stuff. Yeah, series and parallel. Exactly. So what I'm going to do is I'm going to make these two resistors that are in parallel as one super resistor. So here, let's label them. I'm going to call this like R1. I'm going to call this R2. I'm going to call this R3. Okay? So what I'm going to do is I'm going to try to identify different chunks of what's going on. And my goal, the goal, is to get a single battery thingy with a single resistor in between. If we can get to this, then everything is easy to solve, and then it's just about working backwards. So, yeah. So what I'm going to do first is I'm going to look at these resistors here, which I know is a 6 ohm and a 3 ohm. Nice. Or actually, I'm going to leave I'm going to leave the numbers out for now. So I'm going to say that's R2 and R3 in parallel. Which things in parallel, you add up there's a name for this, but basically like 1 over R23, so the total resistance between these two is equal to 1 over R2 plus 1 over R3. It's called harmonic. Thank you. Yes, it's called harmonic. Harmonic averaging, I think is what it is. So this whole thing here, one sec, TikTok's making me verify something real quick. One sec. Yeah, there you go. Verification complete. Okay. This is equal to R23, which is equal to 1 over R2 plus 1 over R3. And that's what this new thing is. This new thing is this new super resistor, which we'll call R23. And actually, maybe I should get numbers for this because this is just going to get fucking messy. So let's do that real quick. So R2 is 6. So we had 1 over 6 plus 1 over 3. 1 over 3 is the same thing as 2 over 6. So this is equal to 3 over 6. So 1 over R23 is equal to 3 over 6. So flipsies, R23 is equal to 6 over 3, which is equal to 2. Okay? So now this is a super resistor of resistance 2 ohms. That's what we've now converted this whole thing into this. Okay. Now, here, let me like put this down. Now we have a 2 ohm and a 4 ohm in series with each other, and this is easy. Because I can draw these two things as one super resistor in series, which is equal to 4 ohms plus 2 ohms. So now this here right here is was R23. This is now going to be R123. And that thing is going to be equal to 6 ohms. This is circuits. So if this is 6 ohms and this is 18 volts, now we have a very simple situation. And what you can do is you can just use V equals IR. So V equals IR. In this case, it's 18 volts is equal to the current times the resistance, which is 6 ohms. So good. So the current is equal to 3 amps, and the overall resistance is equal to 6 ohms. And that's your answer. Nice. That's a fun one. I like circuits. Circuits are cool. Faint as it says, solve that rotational disk from JEE Advanced Dude, isn't the JEE exam like nightmare hard? I feel like it's like insane. It's an insane test to do. That's the one that like determines like who gets to go to college and who has to like subway surf, right, in India. Is that kind of what happens? Yes, good. Now go backwards. No, that's the best one. No. He's so right. Yes, Silfire was saying, yeah. So once you get the total current running through this, you can then go backwards. And so what I like to say is you take all these resistors and you like group them together into one big resistor, and then you take this thing and then you start expanding it back out to figure out all the components. And the cool thing here is that if this thing has, for instance, 3 amps running through it, then these two things also have 3 amps running through it. So this would have an amperage of 3, and this would have 3 amps running through it as well. Because things in series have the same current, but now they have different voltages. And this is where you do V equals IR for this one as well. So here you have 4 ohms, you have 3 amps. So this one's going to pull 12 volts, and then this like super thing here is going to pull 6 volts. And then here's the cool thing. The 12 volts and the 6 volts adds up to the total 18 volts. It gets really fun with, yeah, no, bro, don't do it. Yeah. Slipfire is saying that, like, yeah, when you start having multiple power sources, then you have to start doing Kirchhoff loop laws. And sometimes you have to do what's called, like, mesh analysis, which really starts messing with me.
You done messed up, Aaron!
Yeah. Like, when you have multiple batteries in it, then you have to start doing junction laws, loop laws. Sometimes you got to do network analysis, whatever. It's, what's it called? Like, Thevenin voltage? That's the other one? Yeah. Okay. Let me see about this one coming up here. Yeah, glad to see it. Yeah. No, I've taught a decent amount of double E. Thevenin. Thevenin? I don't know how you pronounce it. Thanks, dude. Okay, here we go. This was the physics question that Nini posted. So it said, a machine at a post office sends packages out a chute and down a ramp to be loaded into delivery vehicles. Find the angle of the slope down with which the box would move at a constant velocity, assuming the coefficient of friction is 0.1. You may neglect air resistance. This is a very good question. And I understand why this is scary. Because you don't have the mass. You're like, I don't have the mass of this thing. How can I do it? Well, it turns out it's going to cancel. And I'll show you why. It's really cool. Okay, so coefficient of friction. We're going to assume this is mu k is equal to 0.1. Because we assume it's moving, it's sliding down. So this is an okay attempt. There's one thing wrong with this, and that's that the normal force does not point straight up.
No.
The normal force always points normal, which means 90 degrees, to the surface it's on. So the normal force actually points this way. It doesn't point straight up. Gravity does point straight down. And we're going to go into like why that does some weird shit. So if, again, in my inclined plane, here, and I'm going to let me just put this somewhere else down here. If for my inclined plane here, I have a box, okay, and I have the force of gravity always points straight down, okay, then we're going to have some normal component here, which is going to point 90 degrees to the axis that it's on, okay? This is kind of a weird way to look at things because I'm talking about it going down here at like a constant velocity, right? And first of all, if it's falling down and there's friction, okay, friction opposes where this thing wants to go. This thing wants to go down, so friction is going to apply directly this way, and this will be Fs, okay. The issue with this, as it stands, is that these are like diagonal forces now. Do you see how Fs like points up into the left and Fn points like up into the right? It gets very complicated. And also, I only care about the acceleration being 0 in like this direction, right? Down the plane. So what I'm going to do is I'm going to take my diagram here and I'm going to do what's called components, right? So I could, e to the 2i pi is right. I could do components on Fs and Fn right now, and then try to get them also to match A. But the easier way is what we call rotating the frame. And so I'm just going to rotate my situation like this. Okay? So now, and I understand this is not perfectly straight, the problem. I can only get so close. Okay, well, here, let me draw this straighter, because this is going to bug me to no end if it's not. It's like, let me, I need to draw this parallel. This is like a parallel competition here. Okay, and then this, by proxy, I think needs to also be 30 degrees, or it needs to be 60. Or whatever. Yeah, I think it needs to be 60. Okay, there you go. I think that's it. Coordinate change. Yeah, we do this all the time. Default user says, I did research on integrals, by the way. I get the concept, but how? What's the difference from them in dx? Yeah, sure. I can show you a simple integral. That's cool. We can do one. Okay, so I'm going to rotate this. This way. Okay. And so now, look, normal force points straight up and down. Friction points straight left and right. The acceleration I'm worried about points straight left and right. But gravity is now pointing at an angle. But this is not bad, because all I'm going to do is break this up into components, which we're going to call FGY, because now this is pointing down, and FGX, which is pointing this way. And FGX is what carries this block down the ramp. Okay. So, now we're going to do our sum of forces. So sum of forces in the x direction. So I have FGX pointing to the right, and then I have minus force of friction pointing to the left. And this has to equal 0, because I said I want the acceleration of it down the plane to be 0. I could do an Atwood problem, yeah, for sure. Now, in the y direction, okay, so let's look at the sum of the forces in the y direction. I have Fn pointing up. I have FGY pointing down. And then that's also it. And that's also equal to 0, because this thing is not falling down into the plane and it's not bouncing up. Okay. This is where you want to start like trying to write things in terms of the same variables. And so what I know is that this angle here is theta. And if this is theta, this is also theta. It turns out you can do a triangle argument. You can say that, oh, if this is 90, then this just must be 90 minus theta. But then this is also 90. So 90 minus theta and theta, that means this is just theta. So I'm going to say that FGY here is going to be, this is going to be the cosine of this angle, right? So this is going to be FG cosine theta. This is going to end up being FG sine theta. And now we can start replacing things. Okay, so here, let's start putting some stuff in. So instead of FGX, I'm going to say FG cosine theta minus, and then the force of friction is mu k Fn. Now, Fn here is the same Fn here. So let's try to use this equation to maybe solve for Fn. So here, I get that Fn minus the force of gravity, which is FG, FGY, sorry. So that's FG cosine theta is equal to 0. So now I can solve for Fn. And I get, oh, well, Fn is equal to FG cosine theta. So now this, mu stands for the coefficient of friction. This is how, like, sticky the surface is. So this is going to come into here. Okay? And so now I have FG cosine theta minus mu k. No, one of these needs to be sine. I fucked this up. One sec. FGY. FGX is FG sine theta. My bad. I fucked this up. I was like, wait, I need a sine and a cosine. Sorry. FGX here is FG sine theta. This is going to be FG sine theta minus mu k FG cosine theta is equal to 0. And then watch what happens here. This is really, really cool. I can move this over to the right, and I get FG sine theta equals mu k FG cosine theta. Now the FG's cancel. So I don't need to know what the force of gravity is. I don't need the mg's at all. And I'm left with this. Okay, cool. Mu k equals this divided by this, sine theta over cosine of theta, which is equal to the tangent of theta. Okay? So they wanted to know what the angle was in order for this to go at a constant acceleration, so I got to solve for theta. That's inverse tangent of mu k gets me theta. And this is a very important result. This comes up all the time in physics. If they ask for, like, what angle do I need in order for this to start falling or to fall at a constant rate, it's equal to the inverse, the arctangent of the coefficient of friction. This is kind of confusing. Okay, let me explain it then. Yeah, dude, yeah, the curved, the banked ones. Yeah, okay. All right. Let's see where things were confusing first. Okay. Do we understand here? Do we understand labeling all the forces, Nini? Like, do we understand that this one is FG cosine theta, and then that this one is FG sine theta? I could color code this better, probably. I was getting excited because I'm like, oh, this is such a fun one. Okay. So now, all you do is you write out the sum of the forces in the x direction, okay? There's FGX pointing to the right. So we're calling this positive and this negative. So that's going to be FG sine theta. Here, let me maybe, like, color code this. Well, I'm running out of colors. I've used all my colors. Here. This is the same as this, which is the same as this, okay? And then we're doing minus the force of friction, okay? That's just pulling it back. And that was this one, okay? And that's equal to mu k Fn. And then the sum of these forces has to equal the mass times the acceleration in the x direction, which what we said was that it moves down the box at a constant velocity. Constant velocity, so constant v, means a is equal to 0. Yes, no, I agree, Cookie, yeah. Okay, so do we understand this so far? Is this okay? Is this all kosher or whatever things? And this is just for the y direction. This is for the x direction, sorry. Okay, so now in the y direction, I have two forces. I have Fn pointing up, and I have the y component of gravity, which is pulling it down in our, like, new coordinate system. So for that, I have Fn minus Fgy is equal to 0. Or I could say Fn minus Fg cosine theta is equal to 0, which also allows me to just... So here, this is the y direction. Do you have the distance it's been falling for? You actually don't need it. You don't need the distance it's been falling. Because we just want to figure out when the acceleration is 0, so it's constant velocity. Okay, so do we agree with this for y direction, x direction? So if this is in x, good, and then this is in y, now what we need to do is solve for, we're trying to get theta, right, is what we're going to get. But I also know that I have an expression for what Fn is. So, okay, the final equation for x. So this one right here. So this is the force of gravity in the x direction, which is this, which is pulling it to the right, minus the force of friction in the pink here, which is pulling it to the left, which was just Fs. But what we learned is that for friction, so friction force is equal to mu k Fn. So that's how we get this. So Fg sine theta, which points in x, for the gravity, subtracted from the force of friction, mu k Fn, that will all equal to 0. Now, for the y direction, right, the normal force cancels out the gravity y component, which is Fg cosine theta. And this allows us to come up with an expression for what Fn is. So now I know, oh cool, well Fn is Fg cosine theta, which means I can plug that in for here, for Fn. So that's what happened when we got this. So now I have Fg sine theta minus mu k Fg cosine theta is equal to 0. So this is what I would say is like kind of like my combined equation. So this is combining x and y equations. Because I solved for one variable in one direction and I plugged it in for the variable in the other direction. What's up, Alt? And at this point, it's kind of just algebra. But what I notice is, if I move this over to the right, so the block is moving up the incline. Oh, no. It's moving down. What happened here is I defined this direction here as being positive. And this is negative. I defined the directions. Right? You see here I said, well, positive's going this way and negative's going that way. And that's why gravity points in the positive direction for the x component. Okay. So once you're here, you can then move this over to this side. And now you notice how you have FG on both sides? That allows you to cancel those. So this will cancel out with this. And then here, because I was kind of like rushing some steps here. So now, I have sine of theta is equal to mu k cosine of theta. And I can take this and I can put it over. Put it under, right? And then sine over cosine is the same thing as tangent of theta is equal to mu k. And so the last thing to solve for theta here is to take the arctangent of both sides. And then arctangent and tangent cancel each other out. And so you're just left with theta is equal to the arctangent of mu k. And this is your final answer here. Do you see how that works? It's kind of like a big little map and stuff. Dun, 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 dun. Oh, wow. Ooh, someone gave me a stats question. I like the stats question coming up. Very nicely done. Thanks, Cookie. Yeah, so let me know, Nini, if that makes sense to you, Nini. Or if you need me to explain other steps. What's up, Ethan? Good to see you.
Hey, I got some good news to tell you.
What's your good news, dude? What's up? What's your good news?
Oh, okay. It's kind of like, I feel like I'm in a video game when I explain this, but
okay.
I'm kind of proud. So, you know how high school has 4 years, right?
High school does have 4. For most. I mean, it can have more for some.
You done messed up, Aaron!
Yeah, I know. I can have 5 years. I've seen.
You could do a victory lap. Yeah, you can do some victory laps. All right, keep going. What's up?
It's just so throughout my 4 years of high school, no one in my class has ever gotten a 4.0 GPA, like overall.
Okay. No one has ever had a 4.0 GPA?
No, like the max we can get is 4.5, but no one has even gone to 4.0 GPA. Like literally no one. Not even like the smartest people in our class have gone there.
Oh wow. And wait, do you have a 4.0? Is that the story here?
Here's the thing. So let me tell you this. From the beginning of this year, when I started a new semester, things were going well. Grades were looking up until I got too egoistic to the point that my grades dropped all the way down.
Uh-oh.
Yeah, so it's like climbing a mountain. I was actually doing good until I got too egoistic and I fell all the way down. It's like I fell to where I placed first semester. Then
Uh-huh.
here's the thing. It was mid semester, and I told myself that this is where I make a comeback,
Yes, dude.
which is what I call my comeback era. My comeback era.
Okay. Yeah, we call it
And
redemption
with
arc. Hero arc. You gotta have the hero arc, dude.
All right. But with the power that I have, I decided to take every chance I got and just straight up max out the grade as much as
Yeah.
I can.
You went for some grade maxing?
Yes. So then I started like I did keep like I take 11 subjects. I think I had like 2 A pluses still yet.
Okay.
Before. In mid semester. But as time kept going on near the end, I started to see some more A pluses.
Nice, dude.
And right now, currently, I have 7 A pluses.
7, dude. Wow. That's super dope, dude.
And the thing is,
It
that
average-
it's like it's still not done yet. It's still not done. Possibly.
Okay.
I might
Well, you
get either 8 or 8 pluses.
Nice. That's dope, dude.
Either.
Yeah, you're doing
So I
yourself a
still
favor,
have-
dude.
Yeah, but here's the thing: is that there in my class I take computer science, but then there's
Okay.
the science people who have much higher GPAs than us. But
Okay.
the surprising thing is that I'm actually like equal to them. I'm like either I'm
hell yeah, dude.
kind of like higher. Like they have been in the 4.0 GPA all high school year, but me
Mhm.
just starting off new, I'm already surpassing them, and I didn't even know that this was possible.
Dude, yeah. Well, a lot of people, again, I think someone in the chat here was talking about this, which is that, yeah, even if you're like smart, it doesn't necessarily translate to grades because a lot of people are lazy. The hardest working person, honestly, does the best. I mean, intelligence will get you to a point, but don't worry, default. I did not worry about the simple integral. We have quite a queue of questions that have gotten asked here so far, so I have to go through all these.
So far, like I'll need a 4.27 GPA to get 4.0 overall. And you want to
Okay.
know where I'm at right now?
What are you at right now?
4.23.
Ooh, that's close.
Good
That's close, dude. That's close.
I'm ultra close. I'm ultra close at this point.
Nice.
The only thing, like, here's the thing. I got extra points for physics because I participated in sports day. Actually, I did a little mini chess tournament and I got second
Oh, nice.
place.
How'd you do in the chess tournament, dude? How'd it go?
I got second place.
Wow. Nice, dude.
And I just did not feel like beating myself up because, like, why beat myself up over one thing when there's like
There are
more
so many
important
things.
ahead of me?
Yeah. Also, like, I always say in life, like, don't take anything too seriously.
Yeah,
There's a lot going on.
for real.
For real, dude. There's
Yes, bro.
yeah, you're okay.
But what my point here is that it's like yeah. So I get 7 extra points. I'm questioning if that will even get me to an A plus in physics. I hope it does.
I hope
And
so
then
too,
there's
dude.
this other teacher who teaches me information technology. This man decides to go ahead and settle in a game of checkers.
Checkers, dude. What? Who still plays checkers? Excuse me?
Yeah, he challenged me to play checkers.
I don't even
Again,
think I can play
A+
checkers
to
at this
see-
point. Yeah.
I'm
Eigenvalues of a
questioning if I can
4x4.
even-
Get out of here, Adonis.
Obviously, don't
No.
go do that.
So
I'm
what?
questioning if I could even get. I'm questioning if I could even beat this teacher in
Yeah.
checkers. Then
I would hope you
maybe
can.
he'll give me
Checkers is not a very complicated game.
Well, how do I get better just within a day? Because I
That's
have until
true.
Friday to do so. How do I get better?
Why do you have to beat him? Is that part of like the contingency for you to get a better grade in the class?
Yes. Yeah, that's like the.
Wait,
So
did I
like,
miss something?
what do I
here?
do?
Oh.
Sir, what's the goal? What do I do? How do I get better in just within one day?
I don't think it's gonna happen, unfortunately.
What? You can't be serious, right?
Sometimes, dude, things can't happen.
Oh my gosh. Let it go. Really? There's no hope.
Yeah, I know. There's no hope, dude. Unfortunately. Wait, one sec. Where did I fuck this up, dude? Oh, this is 5n plus 2 factorial. Sorry. I'm going through Dry Nose's question. All right, Ethan, that's cool. I have to finish up a student's question here right now, but I appreciate the update.
I'll leave,
I'm glad
I'll
you're doing well in class.
Thanks. I'll see you later.
All right, cool. Good job, Ethan. Okay, Drynos, this was your question, which was, anytime, bro, you see like factorials and this shit, it's always the ratio test. So just like plug in n+1 and then multiply it by the reciprocal of this. And then, I mean, I've been doing this. I hope you've been following along, but you keep going with this until is x just equal to 7? These are the most boring. These are the most boring things. Are can you do the eigenvalues of a 4x4? No. I will not do the eigenvalues of a 4x4. That's ridiculous, dude. What? You want me to take the determinant of a 4x4? Get out of here. I can get a computer to do it for me. Dun dun dun. What's up, Mondo? Okay. Now here's my question, actually. I feel like this is always convergent, right? Because the limit as n goes to infinity of this, bro, this is massive. This is order factor n 1, 2, 3, 4, 5. This is n to the 5th. Whereas this is just over n. So this is always going to be convergent. I mean, I could have kind of just seen that. Like, this factorial is going to beat out this factorial. And then I could give two shits about what the fuck, like, x to the n does. Yeah. So I think this is for all x. I think it's always convergent. I went through and did it explicitly, but I'm pretty sure you can just... So here, we can get ChatGPT to solve it real quick. I'm going to throw it on the high one. It's going to say, I'm pretty sure it's convergent everywhere. This question is way longer than the ones I get in school. Yeah. I mean, yeah, here we go. Yes, so the radius of convergence is infinite. It's convergent for all x. Are you some kind of a math wizard or something, he says? I like to think I can do magic.
That's dope.
How would you go taking a factorial of a non-whole number? I don't know. Ask Zach. Zach probably knows about that one. I don't know how to take the factorial of a non-whole number. I do teach a lot of math and science and a lot of different things. Jeff says it's a gamma function. Ooh, okay. Jeff says gamma function. Yeah, no, it is. Anything in math is possible, but usually just gets a lot more complicated. Okay. Here, default user, you wanted me to do... You do just subtract 1 and multiply, but then the issue is that it gets weird if it's a fraction. Like, I don't think it's 5 minus 1. Like I don't think 3/2 factorial is 3/2 times 1/2 factorial. Is that true? Can we talk for 20 more minutes? I want to go get dinner with my sister. She's been waiting. But I will do a couple more questions. Bessel, this is a cool question. I like that you asked this. I'm gonna do the integral thing for default user real quick because he wants to learn about integrals. But just know that I see you and I appreciate you. This is this like so first of all, is yxx the same thing as d squared y dx squared? Is this like the wave equation that we're talking about? And then this is like dy dt. Cool. Okay. This is cool. I don't think I'll have time for it today just because we've already been going for 2 hours, but let me help out. Default user. This is cool. This is a cool question. This is a diffie-q question is what this is. Okay, so you wanted to learn about integration default user, right? So let's say, for instance, I have... okay. Let's say I have y is equal to... let's say 2x plus 1. And I want to find the integral of y of 2x plus 1 dx. And let's say I want to do it from like 0 to let's say I want to do it from 0 to 3. I'm gonna say 0 to 3. Okay. So, if I were to graph this, right, that means that this point would start at 1, and then it would keep going up this way.
And so when we say integral from 0 to 3, that means we want to start this at x equals 0. Oh, did my baby voice get turned on? Yeah, good job, Ricky. That's the 20 minutes you needed. And this is going to go out to x equals 3. Yeah, good job, Ricky. Okay. So we're trying to figure out this area here. That's what we're trying to do. Okay? One way to do this
is there's a couple ways to do this. I can just do integral rules. So what we learn for this is called the power rule. Anytime you have like x, the integral of x to the a dx, this is the same thing as x to the a plus 1 over a plus 1. So like you raise the power and divide by the new power. Okay? So in this case right here, this is the integral from 0 to 3 of 2x plus 1. That's going to be the same thing as 2. This is x to the 1, and this is the same thing as like x to the 0. Raise the power, so that's going to be 2x squared, divide by the new power over 2. And then that's going to be plus x to the 1, divide by the new power 1 over 1, so that's just x. And then this, if a definite integral yields an area value, the differentiation, yes, it does. So, and it's this, and then it's evaluated from 0 to 3. Oh, thanks for the follow, Rainbow Veteran. Glad you found us. Yeah, follow us. Yeah, like, subscribe, follow, all that fun stuff, please. It helps with our algorithm, so I can keep pumping out math content to filter out all the feet pics and OnlyFans girls.
You done messed up, Aaron!
The world needs more math. Okay. So you do this, and then because these are the bounds, like where you're starting and stopping, you're gonna plug in. Wouldn't it be 0? What would be 0? Do math, not math. Yeah. You're gonna plug this one into the whole thing, so that's gonna end up being. So 2 over 2 is just 1, so that's just gonna be 3 squared plus 3. Okay. And then it's minus plugging this in, which that's just 0 plus 0. So then your final equation here would be equal to 9 plus 3, which is equal to 12. Okay? So that's the area of this. Now, one way we could have also done this is I could have said, okay, wait a minute. This is the same thing as just a rectangle and a triangle. Okay? Which we can figure out what the area of this is, right? Okay, this is the height of 1, right? So length 3, height 1. This has an area of 3. Then this part right here has a length of 2 and a height of 3. So 1/2 base times height, right? So base times height, 6 divided by 2 is 3. Wait, what did I screw up here? One sec. Oh, wait one sec. This is y equals 2x. My bad. Sorry. If this is y is equal to 2x, then this total distance here is 6. So this is 5. Okay, there we go. Hi, my fellow math lovers. Yeah, good to see you, dude. Yes, I can screenshot and send it in Discord when I'm done. Question, do you think Calc 1 Khan Academy course is good, or have you never tried it before? I've never done it. But Khan Academy is generally pretty good. He's a pretty cool guy, right? Actually, sorry, this is 7. I'm like double fucking up today. Okay, sorry. This is 6. Yeah. Okay. Because, okay, right here, this is 3, 7. This is 0, 1. And then this is 3, 0. So this is 1. 1 by 3 gets you an area of 3. This is 6 by 3 for a triangle. 1/2 6 times 3 is 9. Now if you add the areas, you get 3 plus 9, which is equal to 12. And God is not a lie. And integrals make sense. So yeah, that's how they work.
God does not play dice.
God does not play dice. Who said that? Anyone know who said that one? think Einstein is who said it. Einstein said, God does not play dice.
Indeed.
It was. Okay, cool. Yeah, all right, cool. Can you read Cookie's question too? Yeah, I can read it. Give me a second. I probably have to end the stream here pretty soon because I gotta go eat lunch with or eat dinner with my sister who's visiting. Default, what's your name in our is it default user as well? What is default user? There you go. Oh, and you get a coin for also answering your question. Got you, bro. I posted it in the there's a stage chat. Stage chat's there, which is also down here on the vertical. Yeah, okay, good to see you, Reki. Yeah, nice. Yeah, we are gonna go raid someone. We got 19 people here. What was Cookie's question, sorry, before we end the stream? Also, e-girl or ladies had a fun one. Wait, and wait, your mom, ha ha ha. Is this Cookie's question? I got a couple of funny ones people have been I call these these are the fucking Facebook IQ soccer mom genius questions. These are funny. Is this the one you're talking about? And then also this one is also cool to do. Oh, he asked it on chat? Oh, well, I got to go through my chat. And I have a lot of chat. If you haven't noticed, we have chat from TikTok, YouTube, and Twitch all at once. So I have to figure out what chat that's in. Where was Cookie's question? Okay, here we go. There you go. Thank you. This was Cookie's thing. I found it. And then I got it. Yeah. E-girl, this is a great question. I would love to do this one. Can you come by my stream tomorrow? I might have to start streaming multiple days. I usually only do Monday, Wednesday, Friday. Monday, Tuesday, Wednesday. I might have to start doing Thursday. Okay.
7 days a week, 24 hours a day.
Dude, I already stream so much. Like, you want to see what, like, my Twitch? I had to do this we had to file taxes for our nonprofit. So yeah, by the way, we are an official nonprofit. We're a 501c3 whatever thingy. So we do raise money. If you have money and you want to donate it to our nonprofit, which is helping high school kids learn math even when they don't want to, you can do that. But I was doing my analytics on here, the amount because I had to tell the government like what we did last year. If I go from January 1st all the way to the end of December, there we go. So you can see we've been live for 330 hours this year of just streaming math and science help, which has been pretty cool. 95. And let's see how many unique. This is just Twitch. A lot of you guys have found me on YouTube right now. We just started streaming on YouTube, so 4,388 people. If you guys have seen us, it's pretty cool. More gold for the masses. Yeah. People ask me, do I make a bunch of money? Like, okay, well, Twitch has given me $286, so. And all that money just goes to the nonprofit. That doesn't go to me. So.
Jesus, dude, that's what I get paid in an hour.
I know, bro. I mean, I charged $286 last night to tutor a kid, so it's not very much money, but we're working on it. Anyways,
speaking of streaming, just quickly.
Yeah, what's up?
We were supposed to be adding me into all this, and I'm supposed to be teaching people CS. It keeps coming up a few times. People keep asking me CS questions.
Oh, they should ask you CS questions. Sensation knows computer science.
So I am going to come back at some point and actually.
Oh, nice. Sensation Black is Sensation Back.
I think it's great. I'm just so busy.
Oh, that's okay. No, I would love for you to come back. Yeah, please. Yeah, if you have computer science questions, Sensation will be here. All right, I'm going to answer this real quick, and then I gotta go. I really gotta go eat dinner. Okay. So Cookie says, if a definite integral yields an area value and differentiation yields the rate of change at a point, then what is the value of an indefinite integral at a point in context? If a definite integral yields an okay, cool. So an indefinite integral represents what the area could be plus or minus an offset. So if you integrate let's say you integrate, for instance, f prime of x dx, this gets you the regular function f of x, but plus c. Because let's say, for instance, you have a bunch of curves that look like this, right? This could be like we call this like f of x, I don't know, whatever, green f of x, okay? Integrating the derivative of this, okay, will get me a bunch of, no, this is what I should show. Okay, one sec, here we go. Okay. Here we go. Here are 3 different functions, f of x, g of x, and f, g, and h of x. Okay. These functions, in terms of like what the derivative is the same, right? This vertical offset, whether h of x is down here, g of x is here, or h of x, or f of x is here, if I were to then plot what the derivative of this function is, it is the same, because the derivative just measures the slope, and the slope doesn't care about any vertical offset, okay? So, since all these things are the same, when I integrate them, I'm going to get the same value. However, there is a plus c. And the plus c determines basically this. It's like, well, okay, where vertically are you? Because integrating each one of these things is the same, but it's only different by an offset. So that's kind of that's what the value of an indefinite integral is at a point. It's what the area would be plus or minus an offset. The reason why we do this is, the reason why we do indefinite integrals is a lot of times I only care about how much the area is changing, not about how much the area is constant, right? So in this case, right, this graph and this graph, the amount at which the area is changing is constant, because all that's different between this and this is this offset. And so, like, this amount of area for the thing is the same throughout time, but the difference is changing. So that's why indefinite integrals are used, and why they equal to that. Okay, is that cool? Okay, cool. Again, that's a lot of questions today. I had a lot of fun answering all of them. Let's close the stream out. All right. Thank you, everyone, for coming to office hours. I really appreciate all the questions. YouTube chat seems broken. My bad. Why did YouTube get broken? I'm sorry, my YouTube people. Well, actually, you know what? It's in here somewhere. Oh, there you go. Okay. I got it. I got the chat up here. I got them. Wow, we had a lot of views today. Really appreciate all that. Awesome. Yes. Sweet. Okay. So am I streaming tomorrow? I don't plan on streaming tomorrow. But I may start adding that later. Okay, cool. Let me just go through these real quick. Lots of chats. Yes, cool. Yeah, so not planning to stream tomorrow. Our streaming schedule is Monday, Tuesday, Wednesday. If you want the schedule for that. I'm not the only person who streams math or science, by the way. So we have a lot of really other cool, awesome friends that stream math or science. And there's the calendar for when they stream. And then here are their Twitch usernames. Yes, default user. Ping me in the Discord. I'll do it after dinner. I gotta go eat. Anyways, okay, so for our Twitch people that are watching, we're gonna go raid someone else. So what that means is we go find another really fun math or science streamer that's online, and we go join them and say, hey, what's going on? Knock, knock. But yeah, our next planned stream will be Monday, and that will be at 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Central, 6 p.m. Eastern. I think it's 11 p.m. British time, 11 p.m. GMT. I think that's what it is. 11 p.m. GMT. Okay, so who's on? Ooh, I love these people. Okay, these people are great. Ask a Scientist Gaming. These guys are cool. So what they do is, this guy is from, I think, the University of Florida, and he brings a lot of other scientists on to, like, talk about shit, and they play video games together. So this looks like this guy has a PhD in sports analytics. Very, very, very cool. The people demand more gold. Yes. Well, also my rent demands more money. So. Unfortunate. Okay, cool. Have a wonderful rest of your week. Enjoy the weekend. We will see you guys on Monday. Peace out.